Okay, this page where it says arranging people in a row. Okay, number one, you have 5 boys and 5 girls to be seated in a row. How many ways can you seat them if there are no restrictions? So basically, there's 10 people there. And if it doesn't matter about anything, how many people could I put first in the first seat? 10. How many people could I put in the second seat? 9. Then 8, right? So this is also the same as doing a what kind of quick math? Factorial. 10 factorial. It is also the same as doing a 10 P10. Because there's 10 people, arranging them 10 seats, and the order matters, right? It's a permutation because the order of these people matter. If I change, that's making a different permutation. Okay, so remember where those buttons are in your calculator. Where's your calculator? You gotta practice on this one because you can't use your graphing one on the exam. See if you can find that factorial button. Exclamation. Have you ever seen it before? Okay. On the next example, it says I have to alternate between boys and girls. They have to be staggered. So right now, how many options would I have to put somebody on my first seat? Still 10. I can put anybody there. Now I'm going to go to my second seat. How many options would I have? Not 4. 5. Okay? So why don't we pretend we put a boy there? So now we jump to a girl. How many girls do I have? 5. So then this would mean I'd have to jump back to a boy. So now how many am I at? 4 boys. And then 4 girls. Now I'm back to a boy. 3. Back to girls. 3, 2, 2, 1, 1. Okay? So here's the quick math behind this. The boys can be 5 of them getting rearranged. You could put the boys in 5 different spots like that. The girls could also be 5 moving around. But why would I want to times it by 2? Which is why there's not a 5 in that spot instead of there's a 10. That's where it came from. Because 2 options for the start. I could have started my arrangement with a boy, I could have started with a girl. So that's why the whole process got doubled. So if you want to practice that typing, I'm going to show you what the number is and you can look to see if it's the same. So do you see how this is 5, 4, 3, 2, 1? 5, 4, 3, 2, 1. But instead of a 5, I put a 10 in the first spot, right? That's where one of the 5s got doubled. That's why there's a 10 there. And it's because you could make your arrangement starting out with boys, or you could have started out with a girl, which is doubling the movement, I guess. I don't know. Did I explain that okay? Did it make sense? C, draw me your 10 blanks. This time, Andrew and Zach have to sit beside each other. So they're glued together. So when you move them, they're moving together. So if I want to put them in the middle, that's just them moving to the middle or whatever. Okay, here's the first thing I want you to think about. How many items are you moving around? And you're considering this now just its own item. It got glued together as an item. So now we're just moving 9 items around. Because these are 8 individuals plus 1 glued group. So there's 9 items moving around. Then what could Andrew and Zach do within just themselves? They could flip-flop. So that means they can move around. So this is within. Okay, so I want you to do this next question in the same way. But now there's just 3 people that are glued together, best friends sitting together. When they move, they have to move together. Okay, I want you to think about that one on your own. Can you do it? Okay, so for me, I'm counting 8 moves because this is 7 individuals and 1 group. So there's 8. And now within themselves, they can move around. Okay, this time, drawing your 10 blanks. They must sit in couples. So this couple, when they move, they have to move together. This is what I'm doing. So this couple, if they move, they have to move together. They have to move together. Okay, same concept. How many items would you end up moving around now? 5 items, because this is glued together as an item now. Then what could happen within the item? 2 factorial. What could happen in this one? 2 factorial, 2 factorial. Within all the groups, they all could be doing this, switching it yet. So if I was typing this, I would do that to a 5th exponent. Would that make sense to you why I'm doing it? Repeated 5 times. Okay, and the last question on this page. Andrew and Zach don't want to sit beside each other. So this one we're going to use what I'm going to call the opposite rule. Would it make sense within all the arrangements you would either have that they are sitting beside each other or they're not sitting beside each other? Those are the only 2 scenarios that could happen, right? They're either sitting beside each other or not sitting beside each other. So we're going to do this. However many were all possible, subtract the opposite event. What is the opposite event of them not sitting beside each other? If they sit beside each other. Okay, so you have this answer on your page. Which question was the all possible one? Looking up, which one is the all possible? A, B, C, D, or E? A. So that was the all possible. If there was no restrictions, we could do that many arrangements. Minus, we already did this one, if they do sit beside each other. That would be question C. So you're going to have to subtract those two numbers. What does the back part of your notes look like? Is it blank or you had stuff on it? The very, very last. Okay. Blank? Okay, I'm just going to show you two examples. Okay, here's just two more examples. A school has 8 doors on it. How many ways could you go in and out? Okay, so I'm going to draw a blank and a blank. So I'm going to think like this. How many options would I have to go in, and how many options would I have to go out? So how many doors could I possibly go in the building with?
8.
8. I had 8 doors to pick from. And now I'm leaving the building. How many options do I have?
8.
8. So there's 64 different ways I could be going in and out of the building. What if I changed the question to you have to go out a different way? How would that change what we do?
4 ways in, 4 ways out.
Just using the 8 doors still. You have to go in one of the doors, and then you have to make sure you're going out with a different door. So how many options to go in? 8. And then how many options would you have when you're leaving? 7. You kind of understand that concept? How many different PIN numbers are there on your bank card? How many different PIN numbers are there? So we look at that it's a 4-digit. How many options of digits do you have to put into your first selection?
10.
10? How many options would you have as a digit in the second spot? 10, 10, 10. So there are 10,000 PIN number codes.